Welcome everyone and thank you for joining today's webcast. My name is Shivani Hegde and I will be your moderator today. So this is the fourth episode of a series that will introduce you to the product line engineering across development lifecycle with pure variants and its integrations to the various engineering tools. So today's topic is product line engineering and code, that is managing variability in source code. So now I would like to introduce our presenter. So that is Robert Hellebrand. Robert Hellebrand is a senior field application engineer at Pure Systems. He's helping customers with their challenges in efficiently reusing engineering assets and making the transition from project-oriented developments towards the feature model-based product line engineering with pure variants. Next slide, please. So today's topic, like I said, is we will cover the topic PLE and code, that is managing variability in source code, and experience how a typical PLE workflow is structured. And this is the last episode of the series that offers a basic introduction to holistic variant management with pure variants. So we also have a new series covering more advanced PLE topics that is in the planning, and it will be announced on our website soon. So as you can see the link on the slides. And all the webcasts are recorded and uploaded to the Pure Systems YouTube channel. So you can visit at any time. And during the session, you can post questions at any time in the chat system. Only the webcast team can be able to see those questions. So what we will do is we will collect all these questions and ask at the end of the webcast, that is during the Q&A session. And in case there are any open questions left after the Q&A sessions, we will contact you after the webcast in order to follow up. So now with this, I would like to hand it over to Robert.
Thank you, Shivani. Welcome everyone from my side. And yeah, let's start with the topic of today. And I want to start by giving a quick or short general introduction to how product line engineering works with pure variants, and then give a hands-on example of how this is done specifically for source code. So we will cover the different ways that pure variants allows to handle variability there. In general, what there's to say is that pure variants follows the product line engineering approach that contains two concepts. First, we rely on so-called 150% engineering assets, meaning for source code, the idea is that for your whole product line, you have a superset of source code, which contains common parts of code, but also non-common parts. And the non-common part is controlled, the existence of it in a specific variant is controlled by so-called features that live in a feature model. That's the second concept that pure variants makes use of here. In a feature model, you basically hold the information on an abstract level independent from the code that just tells you what can vary between different product variants, like a functionality that is part of one variant but not of another can be expressed as a feature in a feature model. And in this feature model, you also put the information about interdependencies between features. So if you select one feature, is another feature required in combination to make this work? Or are certain features contradicting each other? Are they in conflict with each other and you can only select one of them for a specific variant? Then this information is modeled also here. Besides functionalities that can be modeled as features, you can also, for example, have your markets as features in a feature model to be able to express that you want to deliver the variant to a specific market, and therefore you might have to follow different standards, which might have an impact on your solution assets, including your code. But also, there might be other marketing decisions that you only want to provide certain functionalities in certain markets. And this you would also express with features here. And these features are put into relation with your solution assets. So there will be mapping rules placed on your 115% code to express that certain parts of your code are only needed for a variant if certain features are relevant in this variant. And the same way this is done, and we will see it today for code, we also implemented this approach for other assets, like the same feature model can be connected to your superset requirements, test cases, architecture models, and so on. Yeah, and basically, if you once set up this 150% code base and connected it to a feature model, you can from then on profit from having formalized your interdependency knowledge in the model. You will be able to configure variants in a so-called variant description model that basically shows the features that you have earlier defined in your feature model, and you are in this model selecting features from that feature model that are relevant in a variant-specific context. And all this information goes as input into a so-called transformation step, where pure variants can generate out of your 150% code base the 100% code for each of your variants that you based on the feature selection for the respective variant. And this is what we will have a closer look at in the coming minutes. So we will have a look at the complete workflow here. We will first see how a feature model looks like in pure variants for a front Carlite product line. And then next we will see how to configure a variant based on that feature model, and have a look at the different ways that are available here to establish such a mapping between your feature model and the code initially. And then also have a look at how we profit from this mapping by being able to transform variant-specific code out of a superset. So let's start on the feature modeling side. Typically, what we will see here is what a new role would see, the so-called product line engineer. That's the role responsible for maintaining and building up the feature model and configuring or keeping track of the variant configurations in here. And that role would work or will work with a pure variants Eclipse client, where you can actually build up these models and change them, maintain them. So here we have a look at one such feature model. You can see these models have a tree structure. We will slowly expand this model now and have a look at the different features in there. So each yellow circle you see here represents a feature. You can see each feature has a name and a symbol in front of it that expresses which variation type the feature has. So basically, pure variants here knows about 4 different variation types. You have these features with exclamation marks in front of them. Those are mandatory features, meaning they will be needed in all of your variants. Opposed to that, you have further down in the tree, below low beam, for example, groups of alternative features. So here we have the 2 features xenon and halogen that have these green double-sided arrow in front of them, indicating that there are alternative features, meaning they are mutually exclusive. If the parent feature is part of the variant, which is by default the case here as this is mandatory, then you have to select exactly one of these 2 features for a variant. The same is true for high beam. Also there we can decide to either include xenon or halogen. Then we have here further down in the tree more additional features that show up with a question mark in front of them, like fog lights, daytime running light, driver assistance. This question mark indicates that they are optional. So here you can decide independently for each of those features whether or not to include it. So it would be totally valid to configure a variant that has none of these optional features selected, 1, 2, or all of them selected. All of this would be fine. If we select such an optional feature, then there might be additional children, like in the case of daytime running light, we have additional alternative features, meaning once daytime running light has been selected, we need to decide whether to use reduced low beam or separate daytime running light to implement it. If we decide to include driver assistance into a variant, then pure variants will ask us to select at least one driver assistance system. So we have here multiple ones, all modeled as OR features. This is why they have this blue cross in front of them. With OR features, if the parent feature has been selected, you have to select at least one of the OR features, but you can select more than just one. So they are not mutually exclusive. You can select 1 to n. Yeah, beside these variation types and hierarchy, there are some additional concepts on the feature model side to express interdependencies. And all of these will be resolved during variant configuration. So before we have a look at how to configure a variant, I want to briefly also introduce these additional concepts. So for example, here you can see that static cornering lights has a requires relation of type requires that goes to fog lights, meaning if you have selected the feature static cornering lights, then you actually also need the feature fog lights. That's usually optional, but in that case it will be required definitely. And like this requires type relations, we also have other relation types in the model, like conflicts relations and additional ones. Beside that, you can also, it's also noteworthy that you can span such relations between features of different feature models. For example, here we have not only one feature model that we just had a look at, we also have a second one that holds the regions as features that we sell our variants to, so that we are also able to configure a region for a variant. And we have relations between features from the regions feature model and the functional features feature model. To be able to navigate those relations and see them, we have such a relations view on the right hand side. So at the moment in the main view we have selected the automatic hazard warning feature here. This means the relations view now shows us all the other assets, including all the other features that are related to this automatic hazard warning feature. And you see here there's also a requires relation to the feature Sweden that resides in the regions feature model. By double-clicking on such a feature in the relations view, the main view would jump to the regions model and highlight the feature Sweden instead. Also, if we already had connected code to the automatic hazard warning and requirements and test cases, they would also show up here to indicate that those are assets that will be affected by the selection of automatic hazard warning. So there are additional concepts. I won't go more into detail here. With that in mind, next I want to show how we can configure variants based on those feature models. For this, let's go to the left-hand side into the variant projects view, where we have a so-called configuration space. You can see this configuration space acts like a folder. It holds already some variant models for existing product variants. And we are going to add a new variant model to this configuration space now. And then we will immediately see that it is a little bit more than just a folder. The configuration space actually sets the context for our variant configuration. So in the properties of the configuration space, you define based on which feature models the variants that live in this configuration space will be configured. So here the configuration space points at the functional features feature model and at the regions feature model. We will see the implications of this right now when we are going to add a new variant model in this configuration space. So a wizard will pop up initially that will first ask us to enter a name for the new variant. Here we call it Baselight Sweden. In the next step, we can optionally decide whether we want to inherit feature selections from an already existing variant. This is sometimes useful if you have many variants that will be configured similar to each other. Maybe half the feature selections will be the same. Then you can build or create an intermediate variant where you only make some of these features decisions, the ones that will be similar across all these variants, and leave the remaining decisions open. And then you can inherit in the actual variant models that represent the actual variants from this intermediate model. So you don't have to make this the half of these decisions repeatedly a lot of times. You just can make it in one place. And actually there's a real inheritance relation then established between this intermediate variant and the actual variants. So if you later on also make changes to this intermediate variant, they will flow through to the actual variants inheriting from that one. Here we keep it simple. We just start from scratch with the variant configuration. And now you see we are in the variant configuration view for the variant Baselight Sweden. And as we set the scope of this configuration space where Baselight Sweden model was added to, to both of these feature models, also features from both of these feature models will show up now in the variant configuration view. And of course, if there are relations between features of these two models, they will also be regarded now during the configuration phase. You see, besides the features, that now in front of each feature, there's either a check mark or a box. The check marks basically are in front of each mandatory feature to indicate that they have been automatically selected, as these features have to be part of each variant. In front of each other feature, you now have these boxes that indicate that now you can make the decision here whether or not to include these features into that specific variant. There might be some places where you must make a decision, otherwise the variant is not valid, and these places are indicated by pure variants with help of such error markers as they show up here. If we hover over such an error marker, we also get more details. We get to know what's the issue here. So here we have open alternative features below mandatory features, meaning we have to select exactly one of these alternative features. We can even click on the error marker to then see which decision we can take, and we can decide from there, or we can expand the feature tree and make the decision by selecting a certain feature. And you see, each time we make a decision, we get an evaluation of the whole feature selections in the model, and we get to know which other features now can no longer be selected in addition. Here it's easy because these features are modeled as alternatives. They are mutually exclusive, so by selecting halogen, it's no longer possible to select xenon. But this also works, of course, for cross-tree relations, like the requires relation that we saw earlier exists between hazard warning and feature Sweden. So if we are going to select Sweden now, as automatic hazard warning is required in Sweden, we modeled it this way, pure variants understands this relation and will select automatic hazard warning for you if you have the autoresolver turned on. If you don't like these auto selections, then you can turn the autoresolver off. Then you would, instead of getting this auto selection, you would get an error marker at this point, explaining you, if you hover over it, that actually automatic hazard warning is now also needed, and currently, because of a relation that exists, and currently this relation is hurt, and then you can decide on your own what to do. So that much about the feature modeling and variant configuration part, which happens in pure variants. Now let's have a look at how to initially set up the mapping information between your features and your superset code base to be able to generate later on based on such a feature selection variant specific code. For that we also switch roles, and typically who has the knowledge of what is needed under which condition. This would be the developer in charge or responsible for that part of code. This is now the role who would be active here to add restrictions to express that certain parts of your code are only needed if certain features are active. And actually we can add such variation points on code side on different levels, and I will start on the highest level, which is file and folder level, and then we will go deeper and see how to also add such variation points to more fine-grained places like certain code blocks in a code file or single parameters. So here the idea is that pure variants is initially scanning your 150% code base and automatically generates for it such a family model. So what you see here has been completely generated. The information you can see here, the folders of your 150% source code base. You can see the files in it, C files, H files in this example. And we also added such PS class elements in case you want to have them. They are there for bundling C and H files that belong together, so that you can control with one restriction the existence of both of these files if you want. And the idea is now that you can here express in this family model by adding restrictions to it that certain folders or certain files or certain groups of files are only needed if certain features have been selected. we now have a look at how to do this. Let's say we want to make the files output forklight C and output forklight H variable and only want to have them in variants that actually have the feature forklight selected. Then we can now in this family model add exactly this information. We can right click here this class element. We can say we want to have a restriction here. And now such pure variance simple constraint language editor opens that knows now about all the logical operators and features you can use to write this rule, so the mapping to the feature model to express under which condition these code files are needed. And if I start typing, this list here is filtered down and I can select the feature, for example, I was looking for. Here I just make a simple rule by entering the name of the feature forklights. So the meaning here is if the feature forklights is active in a variant, then both of these files are needed in the variant specific code that is generated out of the superset code base. If this feature is not selected, then these files will not be included when we generate the variant specific code out of this 150% code base. But that's not all. So this way you can add restrictions to file and folder level. Of course, this not only works for code, this works in general for any assets that you have in such a file folder structure. But now let's say you have a code file where you want to control variability inside of that code file. So how to do that? Pure Variance offers multiple ways actually. So I first show you the more popular one, which assumes that you might already, before introducing variability variant management, you might already have some variation points in your code. So what we see this a lot of times at customer side, that there are already some preprocessor commands in use to control the existence of code blocks. So meaning initially, basically there's a configuration file where before preprocessing starts, where actually then certain switches in the code are set to certain values, so that based on this, certain code blocks are included or excluded. And what we can do here is that Pure Variance can now generate, based on the feature selections that you made, such a configuration file and set the values for your code switches for you, so that basically all the interdependency information that you put into your feature model is taken into regard when calculating such a configuration file for you and generating it for you, so that you know that actually the selections here are consistent. The switch values here are defined consistent to each other. And also if you have other assets that you control with this feature model, then you also know that your switch configuration is consistent to the requirements and test case selection, for example. So let's see how this is done, how such a mapping is created to enable Pure Variance to generate such config files. So initially you have to tell Pure Variance under which condition, which flag gets a certain value. And so initially you can start by adding such flag elements to a family model, either manually or you can import them from your code base. So we have done this multiple times with customers to provide such an importer that you can import certain flags of a certain naming scheme into such a family model. And then here you can define again with restrictions under which condition is the value, for example, like we see here, of flag forklight 1, and under which condition is it 0. So here the flag forklight will be set to 1 if the feature forklights has been selected, will be set to 0 otherwise. But of course the rules could be more complex, right? You can also define here into which config file the switch configuration is later written. So here we will see it later, we write all of our flag values into the same config file, but you could also define different places here where this information flows to. If you have also loaded your actual code into your Eclipse environment, then Pure Variance is also using the relations view to tell you on which lines of code this flag has an impact. So then you will see here all the code files where this flag plays a role, and you can click here on the relations view to jump to these places in the code. So like I do here, so I can see, this flag fog light, which is controlled by a feature selection, which value is controlled by feature selection, has an impact on this place in my code. Maybe you are not using any preprocessor commands, then Pure Variance offers a similar mechanism. So instead of having having Pure Variance generate such a config file, you can also let Pure Variance take over the role of a preprocessor. So we also allow you to add to the code by just making a selection of certain code blocks and then clicking up here on an icon that allows you to add a condition to a code block and then open such a editor to make certain code blocks variable. Pure Variance will then put such pv-ifcon and endcon statements around this code block, and in the ifcon statement we will put the feature rule that you formulated with the help of this autocomplete editor. And during the transformation time, Pure Variance will then evaluate or will resolve these statements here, and will then, if they evaluate to true, keep what's inside of that block in the variant-specific code, will only remove the ifcon and endcon statement at beginning and end, or if this evaluates to false, remove the whole block from the code. So then Pure Variance is actually actively taking over the part of the preprocessor, you could say. And besides having the capability here to control existence of code blocks, we also allow here to add calculations. This allows you to inject parametric values from outside that have been defined in the feature model, in the variant model, into certain places in your code. So this is also possible. And before we now have a look at how all these variation points are resolved, I also want to mention that, yes, of course, you can also combine all of these three approaches if you want. So you can, for example, like we will see here, combine the preprocessor commands for which Pure Variance can generate config files with the approach of having restrictions on file and folder level. And let's say you have prepared your 150% code base this way, then you can just configure for a new variant the variant by making a feature selection for it, and then trigger a transformation, either manually, like we see here, by choosing a variant and triggering a code transformation, or a bundle transformation where multiple assets are generated in one go. Or you could also trigger such a transformation headless or via build script. That's also possible here. And then Pure Variance takes this feature selection and the 150% code base as an input and is generating the variant-specific output for you on a predefined place. Here you can see we generated the output locally, so we have here a reduced set of files and folders. Some have been removed, as we have already on that level some restrictions in our 150% code. And we generated this config h file that contains the information which flags have been set to which value based on your feature selection. If you don't like the format here of the file, you can also redefine how we generate this output exactly, how it should look like. With that, I'm at the end of the demonstration. I hope it became somehow clear where the advantages of such an approach are. So to sum up, you now have a with the 150% code base, a central place where you can make fixes to code or can add new functionality to your code, and then can just automatically via a transformation propagate these changes to the variant-specific code bases that need for the variants that need these improvements or these new capabilities. You also have a central place where you store in a formalized way your experts' knowledge about interdependencies. So it's no longer only knowledge distributed over many heads, and maybe that can also vanish when roles change and people switch places in the company or switch company, but you have this knowledge in a persistent and formalized way in a model, so it can be automatically applied for knowing would a variant that is configured this way be valid? Would we have the right assets to generate this or not? And of course, this also allows you to rapidly start new variants, new projects. Yeah? So instead of having to manually go through your variant-specific assets and identify what could be reused, you have an abstract level where you make feature selections, you generate what can be reused from your reusable code base, and you have your resources free to focus on new functionality that hasn't been implemented before in your product line to develop that while having a maximum reuse rate. Yeah, with that, I'm at the end of that part of my part of the presentation. I want to quickly remind you where you can find all the webcast recordings of the past. Yeah? So it's on YouTube. If you look for Pure Systems, you will find our channel with multiple playlists there showing our own recordings, but also recordings from our partners. Yeah, and stay tuned for new upcoming webcasts. So we will have a short break and will then return with a new series of advanced PLE topics after having covered the basics in this series. So with that, I say thank you and hand over back to Shivani.
Thank you, Robert. And yeah, so now we have some time left for questions. You can make use of the chat system to post any questions. So we have a question that is it possible to generate make files based on a feature selection?
Yes, I didn't show this, but that's absolutely possible, and that's actually also done by our customers. So based on this feature selection, you can also generate other different output. Yeah, so we are very flexible on that side, as we know that especially on code side there are many different ideas how we should deal with variability there, and generating make files is also an option.
Okay. So I guess there are no more questions left. I will close the session now. Thank you all for watching and goodbye.